Alright, I'm going to start off by factoring out 9 to the power of x from my left-hand side, because all my terms are 9 to the power of x. And from here, 1 plus 1 plus 1 is going to be 3, so I get 9 to the power of x times 3 is equal to 999. So now I can divide both sides by 3 so we can isolate x. So now I get 9 to the power of x is equal to 999 divided by 3, which is 333. So now we have a much simpler equation from what we started with. So now to solve this, what I'm going to do is rewrite 9 as 3 squared. So now I have 3 squared to the power of x is equal to 333. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. Meaning 3 to the power of 2 to the power of x is equal to 3 to the power of 2 times x, which is just 3 to the power of 2x. So now this is equal to 333. Now what I'm going to bring into this equation are logarithms. And it's always useful to use logarithms when solving exponential equations because they're very helpful. And one of the reasons they're helpful is because they come with an important property that states that log a to the power of b is equal to b times log a. Meaning log 3 to the power of 2x, I can just move this 2x to the front. So I get 2x times log 3 is equal to log 333. And now I'm going to divide both sides by log 3. So I get 2x is equal to log 333 over log 3. Now I'm going to rewrite log 333 as log of 3 times 111. And if I have something in this form, this is the same thing as log 3 plus log 111. Now this is the same thing as log 3 over log 3 plus log 111 over log 3 which is equal to 1 plus log 111 over log 3. Now log 111 is the same thing as log of 3 times 37. So now this is equal to log 3 plus log 37 over log 3, which now it turns into log 3 over log 3 plus log 37 over log 3. And this is equal to 2 plus log 37 over log 3. So now if I divide both sides by 2, these two cancel out, these two cancel out. So I get x is equal to 1 plus log base 3 of 37 over 2. And this is the same thing as 1 plus log 37 over 2 times log 3. So this is my solution to this equation. Alright, so in this video, I'm going to solve the expression 5 to the power of log base 25 of 6. So to solve this, what I'm going to do is I'm going to use a simple property of logarithms that states that if I have something in the form log base a of b, this is equal to ln of b over ln of a. So in this case, I have log base 25 of 6. And this is the same thing as ln of 6 over ln of 25, which is the same thing as ln of 6 over ln of 5 squared. Now another property of logarithms is if I have something in the form ln a to the power b, this is equal to b times ln a. So this is the same thing now as ln 6 over 2 times ln 5. Which I'm actually going to rewrite this as 1 over 2 times ln 5 times ln 6. So now going back, I have 5 to the power of 1 over 2 times ln 5 times ln 6. Now, if I have something in the form e to the power of ln of x, this is just equal to x because the e and the ln cancel out. E times ln is 1, and I can just move the x to the front. So what I'm going to do is if I have something in the form e to the ln 5, this means that this is equal to 5. So I'm going to rewrite 5 here as e to the power of ln 5. So now I have e to the power of ln 5 to the power of 1 over 2 times ln 5 to the power of ln 6. Now these two cancel out, and the e and the ln cancel out. So I'm left with 6 to the power of 1/2. And 6 to the power of 1/2 is, this is going to be the same thing as the square root of 6. So the square root of 6 is my solution to this expression. Now, if you haven't already, please make sure to leave a like, subscribe, and share this video to your friends or family and see if they can solve this. Bye.